So something that will help immensely as you go on in math is going to be remembering that rational expressions are simply really big fractions. That's it. So I can reduce factors from the numerator and the denominator as long as they match. Now you have to keep in mind that just like, so I'm going to show you an example in arithmetic first. If I have something like 6 plus 7 and I put that over 3, okay, you cannot say, oh, well, 3 goes into 6, so I'm going to go ahead and reduce that, because now look what happens. You just said that by reducing that, 6 plus 7 is 13 over 3. If you reduce that this way, what you get is 9 for an answer. And 13/3 is not the same thing as 9. So you have to, in order to reduce fractions, we've got to have the numerator and the denominator in a multiplication format. Now, it's okay to have addition and subtraction within the multiplication, but the bigger picture needs to be multiplication. So looking at our rational expression, we have this chunk times this chunk over this chunk times this chunk. So question number 1 is, can I reduce at this point, or do I have some work to do? Well, I can reduce because I've got a y minus 5 on the top and I got a y minus 5 on the bottom. So that is reducible. So now my reduced or simplified rational expression becomes y minus 3 over y plus 9. You cannot reduce these y's. You cannot reduce the 3 and the 9, because this is now addition subtraction over addition subtraction. It's no longer, so now you're in this case where it's not going to work, okay? So you have to leave this one alone. So this is now completely simplified, okay? So let's try another one. We have a 5z minus 15, and I have a 7z minus 21. So my question is, first of all, can I reduce the way it is? Is it reducible right now? It is not, because I have my bigger picture, even though there's multiplication in the top and in the bottom. My bigger picture is I've got this chunk minus this chunk minus this chunk. So I've got addition subtraction going on in the numerator denominator. I need to factor, okay? So what is the first thing I do every time I factor? I see if there's something common. So what's common across the top is a 5. So when I divide out that 5, I get a z minus 3. Okay, so now do you see that I've changed it from addition subtraction into now it's a multiplication problem? So look at your denominator. Is there anything common between the two terms? There is. So when I divide out a 7, I end up with a 7 minus 3. And it just so happens that my two sets of parentheses now match. So since this is now a multiplication problem, I can go ahead and say any number divided by itself is 1. So my simplified rational expression is just 5/7. Okay, it is just 5/7. So let's look at another one. I've got 15x squared plus 60x over a 5x squared. And this is also kind of weird, okay? This is a fraction that has already been added together with a common denominator. So let me show you in arithmetic what I'm talking about, okay? If we go to arithmetic, hang on, I didn't do a paper. If we go to arithmetic and say I've got x over 2 plus 1 over 3, okay? My common denominator would be 6. So I would multiply top and bottom, and I would get 3x over 6 plus my common denominator. I need to multiply by 2 top and bottom, so I would get 2 over 6. So my common denominator is there. So I get a 3x plus 2 over 6. So do you see that I have a common denominator of 6, and I'm just a lazy math person, so I wrote everything in the numerator over my common denominator. Why is she saying all this? Come back down here. I now have 2 terms in the numerator. This denominator belongs to both of those, okay? So what I'm going to do is I'm going to change my numerator into, I'm going to factor it and see if I can reduce that way, but I also want to show you kind of a shortcut that way. Okay, so what I have here is what's common in the top. I can pull out a 15x in the top, and that leaves me with an x plus 4 over, this leaves me with a 5x squared. Okay, so now I've got 15 times x plus 4 over 5 times x squared. So I can reduce my 5 and my 15 to a 3 over 1. I've got x's on top and bottom, but only this is going to be an x over an x squared. So that reduces, so I've got an x left in the denominator. And then my x plus 4 didn't reduce. Okay, my x plus 4 did not reduce. So what I end up with is that as a simplified rational expression. You could also go ahead and distribute this back out and say I got a 3x plus 12 over x. Now, what was my little shortcut? My little shortcut is this, and we're going to write in red this time. I've got a 5, a 15, and a 60. What's the number that will go into all of those? 5, 15, and 60. I can pull a 5 out of everything. So I'm going to divide all 3 chunks by 5. Okay, so that gives me a 3, that gives me a 12, and that gives me a 1 here. So 5 divided by 5 is 1, 15 divided by 5 is 3, 60 divided by 5 is 12. Now look at x's. What's the most amount of x's you can pull out? I can pull a single x out of everything because he's got the least amount, so that's the most I can pull out of everything. So I'm going to pull an x out here, an x out here, and an x out here. So that gives me an x and an x here. Okay, so that is exactly what I got down here. Now for a while, it's probably going to be easier to factor it out. But one of those things that I just do that math people do lazily is I'm like, okay, I got to reduce everything, so what's something I can pull out of everything? And I can pull out a 5x from everything. And so I would just kill off a 5x from everything. All right, so let's do the next one. And what I have is a 2y minus 4 over a 5y minus 10. So this is a rational expression. Is it ready to be reduced? No, it is not, because I've got addition, subtraction on top and bottom. So I need to change it into a multiplication problem. So what is the biggest thing I can pull out of both terms? I can pull out a 2 from both terms on the top, and that'll leave me with a y minus 2. What's the greatest common factor on the bottom? I can pull out a 5 from both terms, and that'll leave me with a y minus 2. And now it's multiplication. So now I can divide anything that matches. Okay, so any common factors. So y minus 2 divided by y minus 2 is going to be 1. So my simplified rational expression in lowest terms is 2/5. I have a 7p squared minus 7p over 2p minus 2. Okay, so immediately I notice that there's a pattern. I got 7s on the top and I got 2s on the bottom. So what else can I pull out? On the top, right now I have to reduce first because it's addition, subtraction on the top, addition, subtraction on the bottom. So I've got to change it into multiplication. I'm going to pull out a 7p on the top, and that will leave me with a p minus 1. Remember, it's division. So 7p divided by 7p is 1. Over, what can I pull out of the bottom? A 2. So that's going to leave me with a p minus 1 because it's division. So do I have anything that matches that I can reduce by? Yeah, p minus 1 over p minus 1 reduces to a 1. So my answer is 7p over 2. Okay, and you could change that 7 over 2 into 3.5, but I don't want to do that. So math people like fractions the higher up we get. So don't go to decimals unless you're told to. All right, so I've got a 4t minus 8 over a t squared minus 4. All right, so is it ready to be reduced? No, it is not. I got addition, subtraction across the top and addition, subtraction across the bottom. So I need to change it into a factored form. First thing I do every time I factor is see if there's something common. So I can pull out a 4 on the top, and that leaves me with a t minus 2. Well, there's nothing common on the bottom, but I remember from previous sections that this is the difference of two squares. So that's going to give me two sets of parentheses. One gets a plus, one gets a minus. And then the square root of the first goes in the first spot. Square root of the second goes in the second spot. And now I notice I've got a number divided by itself. So my final answer is going to be 4 over t plus 2. Don't reduce the 4 and the 2 because now you're back into a situation where it's addition subtraction. So you're done. I cannot go any further. That's as far as I can go to reduce that. All right, we have a z squared minus 9z plus 18 over z squared plus 2z minus 15. So, can I reduce right off the bat? No, I cannot, because this is all connected with addition subtraction. This is all connected with addition subtraction. So I cannot reduce the way it stands. I've got to change it into a multiplication problem, which means I need to factor my numerator and factor my denominator. So what's the first thing I do every time I factor? See if there's something common. There's not. But I do know how to factor another method of factoring, and that's factoring a trinomial. So do I know two numbers that multiply to 18 that add up to negative 9? I'm multiplying to positive 18, which means my signs need to be the same. And then I need to add up to a negative 9. So your signs are both going to be negative. So a negative times a negative is a positive. So now when I do that, I notice that that is my setup right there. So my numerator becomes z minus 3 over, or times z minus 6. Good heavens. All right, the next one is, I'm going to look at the bottom. Is there anything common across all three terms? No, there's not. But I can factor a trinomial, or I can try to. So what are two numbers that multiply to negative 15? So your signs are different. And your larger factor will take the sign of the middle term. So my options are 1 and 15 and 3 and 5. So my larger factor will be positive, which means my smaller factor will be negative. So 15 minus 1 is 14. 5 minus 3 is, there's your 2. So this factors down to z minus 3, z plus 5. So now I notice I've got factors that match. They reduce. So my final answer for a reduced rational expression is z minus 6 over z plus 5. Okay, don't reduce the z's because you're back into an addition subtraction problem. All right, so let's try another one. We've got a z squared minus a 6z plus 8 over z squared plus 5z minus 36. Okay, so can I reduce now? No, I cannot, because it's addition subtraction across the top, addition subtraction across the bottom. So I need to change it into its factored form. So is there anything common across the top? No. Is there anything common across the bottom? No. So I'm going to go ahead and factor both of these. I need two numbers that multiply to positive 8 that will add up to a negative 6. So it's going to give me a negative 2 and a negative 4. So negative 2 times negative 4 is 8. Negative 2 plus negative 4 is negative 6. I need two factors that multiply to negative 36, so your signs are different. The larger factor will be positive, and that's going to end up giving me a positive 9 and a negative 4. And now see if anything matches. I've got a z minus 4 over a z minus 4. Any number divided by itself is 1. So my final simplified rational expression, or my rational expression in lowest terms, is z minus 2 over z plus 9. Do not reduce the z's. All right, I've got a 2y squared minus a 5y minus 12 over a 2y squared plus 15y plus 18. All right, so can I reduce it now? No, I cannot, because this is addition subtraction. This is addition subtraction. Is there anything common across the top? These ones have y's. These ones are both even, so I could pull out a 2, but there's nothing across all three terms. There's nothing across all three terms. So now I need to factor. So this is where I've got my lead coefficient. So I'm going to multiply the first and the last, and that gives me a negative 24 y squared. So I need two numbers that multiply to negative 24y squared, so different signs, that will add up to negative 5. So I need to walk through and figure out what my list is. I've got a y, or a 1y and a 24y. I got a 2y and a 12y. I got a 3y and an 8y. And I got a 4y and a 6y. So my larger term will be negative. So he's negative, 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 negative. So 1y minus 24y's is negative 23y's. 2y's minus 12y's is negative 10y's. 3y's minus 8y's is negative 5y's. So trash your middle term. So I get 2y squared, positive 3y, negative 8y, minus 12. And again, it doesn't matter if you put the negative 8y first, you'll still get the same answer I do. All right, so what's common on your first two? I can pull out a y, which leaves me with a 2y plus 3. What's common on your last two? It's leading off negative, so whatever you do, pull out a negative, and I can pull out a 4. So that leaves me with a 2y plus 3. So what is in parentheses is 2y plus 3. What is not in parentheses is y minus 4. So my numerator just became 2y plus 3. My denominator is y minus, or sorry, what? My first, I don't even know what that just was. 2y plus 3, y minus 4. Sorry, I was talking numerators and denominators. All right, so let's look at this bottom one. I've got a lead coefficient, so I need to multiply first and last. So that gives me a 36 y squared. I'm multiplying to a positive, so my signs need to match. And it needs to be positive because I'm adding to a positive number. So I've got 1y and 36y. I've got 2y and 18y. I've got 3y and 12y. I got 4y and 9y. I've got 6y and 6y. So looking at that, all of them are positive. I need it to add to 15. So here is my set of factors. So I've got a 2y squared, trash your middle term, and put in what we just found. And now look at your first two terms, what's common? Let me scoot this up. First two terms, what's common? I can pull out a y. So that gives me a 2y plus 3. Look at your last two terms, I can pull out a 6. And that leaves me with a 2y plus 3. So what's common in the parentheses and what's left when you divide it out? So that means my denominator becomes 2y plus 3, y plus 6. So we've changed our addition subtractions into multiplications, and any number divided by itself is 1. So that ends up being a y minus 4 over a y plus 6. You can leave the parentheses or you can take them off. It doesn't matter. But don't reduce the y's. Don't reduce the 2's out of the 4 and the 6. Because you change it into a multiplication problem. Or an addition subtraction problem. All right. Last example. So this is going to be a longer video, sorry. Is 6x squared plus x over 5x to the third, and then minus 19x squared, and minus 4x. All right, so first thing we do is, can we reduce anything? Not now, because it's an addition subtraction across the top, addition subtraction across the bottom. So I'm going to rewrite, let me just look at my numerator first. And first thing I do when I factor is see if there's something common. Everything's got an x. So divide out an x. And remember, when you're dividing that out, do not let your last term fall off, because x divided by x is 1. Well, now I need to see if I can factor this. Okay? So when I have, I need to multiply first and last. So that gives me my 5x squared. And the only factors of 5x squared are 1x and 5x. So do they add up to 6x? Yes, they do. Which means I can now take my 5x squared. I have a 5x, a 1x, and a 1. So what's common on my first two terms is going to be a 5x, and that leaves me with x plus 1. What's common on your final terms? Nothing's common, which means I can just pull out a 1. And now tell me what is in parentheses, which is x plus 1, and what is not in parentheses, which is 5x plus 1. Okay, so my numerator just became x times x plus 1 times 5x plus 1. That's my numerator. There he is. Now let's hit the denominator. So my denominator is 5x to the third minus 19x squared minus 4x. So I see that everything has an x, pull that out. So it gives me a 5x squared minus 19x minus 4. So I need to multiply first and last. So factors of negative 20, my signs are different, and the larger factor will be negative. So I've got a 1x and a 20x. I've got a 2x and a 10x, and I got a 4x and a 5x. And my larger term will be negative. So what do I have that gives me a negative 19? 1x's minus 20x's is negative 19x's. So trash your 19x and do a minus x minus 20x, and then finish that out with a minus 4. Okay, so what's common on the first two? Remember, this lead x needs to come along for the ride. So I've got an x common on the first two, which leaves me with a 5x minus 1. Okay, and what's common on the last two is I can pull out a negative 4, which leaves me with a 5x. Hang on and pause. Okay, I was hesitating because it wasn't working out. Hang on, I made a mistake right here. That's a positive x and a negative 20. And I had a negative x. So when I pull this x out, this is going to go positive right there. I'm so sorry. All right, so on this one, pull out a negative 4. When I pull out a negative 4, that'll give me a 5x plus 1, which means I have the lead x right here. And then what is in parentheses is a 5x plus 1. What is not in parentheses is an x minus 4. So I'm going to recopy that up top. So that gives me an x times a 5x plus 1 times an x minus 4. So I've got two things that are going to reduce out. I've got an x divided by an x, because I've changed my addition subtraction problem into multiplication over multiplication. I've got a 5x plus 1 that reduces with a 5x plus 1. So my final answer is x plus 1 over x minus 4. And that is your simplified rational expression.